Welcome to my projectbazaar.com. Now we discuss about the product and energy efficient and adaptive data compression technique for energy conservation in wireless sensor networks. Wireless sensor networks are superior to wired sensing system for the economical side provides that the latter requires a separate twisted shield pair wire connections. Thus, implementation costs for the latter are high. However, wireless implementation cost of the latter are high. However, sensors have to function for the extensive period of time in order to achieve cost minimization and to successfully complete their particular mission. Therefore, conserving that the allocated energy is very important and represent a major dilemma which stands against the wide spreading of this technology. In this paper, a novel local adaptive data compression based on fuzzy transform is proposed to minimize the bandwidth, the memory space, and the energy consumption in radio communication. An evaluation of the compression technique is provided. During this evaluation, the proposed technique is examined using the real temperature data. The results have shown that the proposed technique can highly reduce the overall power consumption by up to 90%. Moreover, a modification of the proposed technique is proposed which improves the accuracy of the recovered signal even with high compression ratios. Now we discuss the flow diagram for the process. At first, the signal is generated and then the start sensing is starting. After sensing the region, the sorting the reading in time period. That is, the amplitude value is sorting according to the time period. Then check whether the signal is dangerous by the process of amplitude and the time. If the signal is dangerous, then set an alarm. If the signal is not dangerous, then check the signal is normal or above normal. If the signal is normal, then continue the process with residual energy above threshold. If the signal is abnormal, then go to the compress with Y member physics function. Then after the residual energy above threshold, then go to the process broadcast effects. It means the compression process will be continued. Otherwise, the broadcast process will be continued and the after sensing will be occurred for the looping structure. Now we discuss the initial running procedure for the process. At first, select the main.m file and then right click in that file, then select the third option run. Now the initial GUI window was opened. In that you can see the several buttons. These are known as the push buttons. Then this axis is represented as axis. Then this one is the edit box. Now enter any one value in the edit box and then click the button generate the signal. After clicking the button signal, the signal is generated and the generated signal is plotted in the axis. The x-axis represents the time period of the signal and the y-axis represents the amplitude value. Here we enter the amplitude value only. Then click the button click. After clicking the button click, you have see the another GUI window opened in the desktop. In that you can see the several buttons check and execute transform and fuzzy compression and estimate. And then two axes are represented in the axis. Now click the button check. After click the button check, the signal is normal or abnormal, which is located in the edit box. Now the signal is normal. Then execute the button execute transform. After executing the transformation level will be shown in the axis 1 with the x-axis nth sample and the y-axis sample amplitude. Then click the button fuzzy compression. After clicking the button fuzzy compression, the data compression using fuzzy will be using. In that, the compressed signal will pass through the axis 2. First axis represent the Fourier transform and the second axis represent the compressed using fuzzy compression. Then click the button estimate. After clicking the button estimate, you can see the several edit box and as well as the several push buttons. First one is actual estimation and the estimation compression ratio and the energy and the RMSE value. First click the button actual. The actual rate of the signal is 274. Then estimated compression is 55, which is shown in the edit 2. Then click the button compression ratio. The compression ratio is 49.9%. The 49.9 which in terms of percentage. For up to the 100, we use the 49.9% is obtained. After that, click the button energy. The energy level of the signal is 321.11 joules. The energy level is in terms of joules. Then click the button RMSE. RMSE is abbreviated as an root mean square error. The root mean square error will be shown in figure 1. The x-axis represents the number of EMF and the y-axis represents the RMSE values. Thank you.